Welcome to Tell Me More Stories Told as podcast. Get ready, because today we have an absolutely incredible true story for you.
It really is. It sounds like something straight out of science fiction. But this actually happened.
We're talking about something that unfolded deep in the vast wilderness of Siberia. Imagine this. It's 1908, a seemingly normal morning, and then boom, the sky over this remote part of Russia just explodes. I mean, with the force of a massive bomb.
Yeah, millions of trees instantly flattened. It carved this event into history, the Tunguska event.
And it's so much more than just a big bang, isn't it? It's this huge scientific detective story that's been going on for over a century.
Absolutely. What caused it? That's the million-dollar question. Was it a meteorite, a comet, something else entirely?
The eyewitness accounts alone are just staggering. People talking about the sky splitting in two, this intense heat wave, sounds that were just earth-shattering.
It paints such a vivid, terrifying picture.
So let's dive right in. We're going back to that day in Siberia, June 30th, 1908.
Or June 17th, if you're using the old Russian calendar back then. It happened around 7:17 a.m. local time.
And the location near the Podkamennaya Tunguska River. I mean, this is seriously remote territory we're talking about.
Oh, incredibly remote. Yeniseisk governorate back then now is Krasnoyarsk Krai. Think vast, sparsely populated wilderness.
But not completely empty, right? Because we have those amazing accounts for people who actually saw it.
Exactly. There were Evenki nomadic people and some Russian settlers, mostly living northwest of Lake Baikal. They saw things.
What did they describe? What was it like?
Well, the accounts are fascinating. Many talked about seeing this brilliant bluish light, almost as bright as the sun, moving fast across the sky.
Like a fireball.
Yeah, sort of, but leaving this thin trail behind it. Then this blinding flash, followed by a huge cloud billowing up, a pillar of fire shooting upwards, casting this eerie red light everywhere.
Wow, a pillar of fire.
And then witnesses said this pillar seemed to split in two, and then it just faded to black.
That sounds absolutely terrifying. And the sound came later.
Yeah, about 10 minutes after the flash, that's when the sounds hit. People described it like artillery fire, just echoing through the forest.
And the shock wave.
Oh, the shockwave was immense. It apparently knocked people clean off their feet, broke windows in settlements hundreds of kilometers away.
Hundreds of kilometers. That's hard to wrap your head around. It really shows the scale.
It really does.
Yeah.
And here's a fun fact. This wasn't just felt locally.
Oh.
No, the explosion actually registered on seismic stations all across Eurasia. The air pressure waves, they were detected as far away as Germany, Denmark, the UK.
Out. Really?
Yeah, even Batavia, it's Jakarta now, and Washington, D.C. picked up the airwaves. The shockwave itself was like a magnitude 5.0 earthquake in some places.
That is incredible. A truly global event from this remote corner of Siberia.
Absolutely. And the weirdness didn't stop there. The after effects were pretty strange, too.
Right, the glowing skies. Tell us about that.
For several nights afterwards, the skies over Asia and Europe were reported to be unusually bright, like an eerie glow.
Bright enough to read by.
Apparently. There are reports, even photographic evidence, from Sweden and Scotland, of photos being taken at midnight without a flash.
No way. How?
The thinking is it was sunlight scattering off high-altitude ice particles, maybe formed or seeded by water vapor, blasted way up by the explosion, kind of like knocked loose in clouds.
Like you see after some rocket launches.
Exactly like that. And it wasn't just visual. The Smithsonian Astrophysical Observatory out in California noted the atmosphere was less transparent for months afterwards. Something was definitely up there.
Okay, so global effects, weird sky glows. But let's get back to ground zero, or near it. Those eyewitness accounts are just chillin'. S. Semenov.
Right, S. Semenov at the Vanavar trading post. It's about 65 kilometers south of the main blast zone. His account is one of the most detailed.
What did he see?
He said the sky literally split in two. He saw fire high above the forest, felt this incredible heat so intense he thought his shirt was actually on fire.
Oh my God.
Then he said the sky seemed to slam shut. There's this huge thump that threw him several meters, knocked him out briefly.
He was knocked unconscious.
Yeah, just for a moment. When he came to, he heard sounds like rocks falling or cannons firing. The ground was shaking, and this hot wind suddenly raced between the houses, damaging things, shattering windows. Just chaos.
Unbelievable. And the indigenous Evenki people, they were even closer, weren't they?
Some were, like Chuchen of the Shinyagur tribe. He was asleep in his hut near a river.
What happened to him?
He described being violently woken up, like being shoved, heard whistling, a strong wind. Then another really hard shove literally threw him into the hut's fire.
Into the fire, wow.
Yeah. He heard trees crashing down all around. Their hut was knocked over. When they got out, they saw trees burning and described seeing a second sun. That's how bright the flash was. It hurt their eyes. Then came loud thunderclaps, multiple strikes, the ground shaking violently again.
A second sun, the sheer terror. And these stories were backed up by reports filtering out, right? Even in newspapers.
They were, yeah. It took time, but reports emerged. The Seer newspaper mentioned villagers much further north seeing a strangely bright, bluish-white cylindrical body moving downwards for like 10 minutes.
Cylindrical, not just a ball of fire.
Right, cylindrical.
Yeah.
It apparently smudged near the ground, turned into black smoke, then came loud knocking sounds. Not thunder. They specified that shook buildings. People panicked.
And other papers.
Similar stories. Siberian Life reported strong ground tremors near Lovat village, 2 loud explosions like large-caliber artillery. The Krasnoyared's paper in Kazimskoye described noise like strong wind, then horrific thumps, shaking like an earthquake, an unusual underground rattle like trains passing.
Like trains underground. That's weird.
Yeah, followed by 50 or 60 artillery-like sounds, then more thumps and tremors. They also saw an ashen cloud to the north. It all points to something incredibly powerful and, frankly, terrifyingly strange.
These accounts are just mind-blowing. It's amazing anyone survives so close. And it sets the stage for the big question. What was it? The search for answers must have started eventually.
Eventually, yes. But it took a surprisingly long time.
Why was that? Just the remoteness?
That was a huge factor. Plus, you have to remember what was happening in Russia in the early 20th century revolution. War, major political upheaval. Investigating a strange explosion in Siberia wasn't exactly top priority.
Right. Makes sense. So when did scientists actually get out there?
Not until 1921, really. That's when Leonid Kulik enters the picture. He was a Russian mineralogist, and he became fascinated by the stories.
He was the first one to really push for an investigation.
Pretty much. He heard the local accounts and became convinced it had to be a giant meteorite impact. He spent years persuading the Soviet government to fund expeditions. He hoped to find this massive meteorite, maybe valuable iron.
So he finally gets funding, leads an expedition. What did he find when he reached the area in 1927? The giant crater he was expecting?
Nope. That was the first huge shock. He gets to the estimated ground zero, and there's no crater. Not a big one, anyway.
No crater. But the devastation was obvious, right?
Oh, absolutely undeniable devastation. But it was weird. Right at the center, in a zone about 8 kilometers across, the trees were scorched, stripped bare of branches, but still standing upright, like ghostly telephone poles.
Standing, not flattened?
Right at the very center, yes. But then outside that zone, for thousands of square kilometers. Yeah, something like 2,150 square kilometers. The trees were completely flattened, all knocked down, radiating away from that central point.
Wow. And you mentioned a shape.
Yes. Later analysis showed the pattern wasn't perfectly circular. It was more like a giant butterfly shape. 2 large lobes of destruction spreading outwards.
A butterfly pattern. That's bizarre. So no big crater, standing trees in the middle, flattened trees in a butterfly shape. Kulik must have been scratching his head.
Completely baffled. He did find some small water-filled depressions, these little pothole bogs, and he initially thought, okay, maybe these are small craters from fragments.
Ah, so maybe it broke up.
That was his hope.
Yeah.
But then he painstakingly drained one of these bogs, and what did he find at the bottom?
Not a meteorite fragment.
An old tree stump, clearly proving the bog was there before 1908. So those weren't impact craters either.
So the meteorite impact theory was really starting to crumble for him.
It was. But Kulik was persistent. He didn't give up. In 1938, he managed to organize an aerial photographic survey.
Flying over it, that must have given a new perspective.
Hugely valuable.
Mm-hmm.
Sadly, the original negatives were later destroyed in a fire during World War II, but luckily positive prints survived. They clearly show that radial pattern, the sheer scale of the flattened forest. Incredible historical documents.
Amazing they survived. So Kulik laid the groundwork, but the real detailed analysis came later with more advanced science.
Exactly. Decades later, in the 50s and 60s, expeditions went back, armed with better techniques, and they started finding things Kulik couldn't.
Like what?
Microscopic clues. Tiny little spheres, silicate and magnetite, embedded in the soil samples, and even trapped in tree resin from that time.
And these spheres were special.
Yes, because chemical analysis showed they had high ratios of nickel to iron. That's a common signature for extraterrestrial material, for meteorites.
Uh-huh. So evidence from space, after all.
It certainly pointed that way. And the concentration of these spheres seemed consistent with the idea of a meteor exploding high up, an airburst, raining down this fine material.
Microscopic messengers, as you said earlier, that's fascinating. Were there other chemical clues? I remember reading something about the peat bogs.
Right. Peat bogs are great archives of environmental history. Scientists analyzed the peat layers corresponding to 1908 and found some unusual isotopic anomalies, weird ratios of carbon, hydrogen, nitrogen isotopes compared to layers above and below.
And these anomalies were only found there?
Only in the Tunguska area, not outside it. Some researchers think this could be the chemical signature of the impactor itself, maybe mixed with compounds formed by acid rain generated by the explosion.
But that's still debated, isn't it?
It is. It's complex work, and not all labs have been able to replicate those exact isotopic results consistently.
Yeah.
So it's suggestive, but maybe not conclusive proof on its own.
Another piece of the puzzle, but maybe not the final one. What about actual fragments? Did they ever find a definite piece of the object? There was that John Stone story.
Ah, yes. John and Findikhanov proposed a specific large rock found in the area might be a fragment. But later, detailed oxygen isotope analysis strongly suggested it was actually terrestrial, probably formed by hydrothermal activity linked to the ancient Siberian Traps volcanic region. So likely not part of the 1908 event.
Another dead end, but the search continued.
Oh, yes. More recently, in 2013, there was some excitement. A team analyzed microsamples from a peat bog near the epicenter very carefully. They found tiny fragments, really tiny, that they believe might be extraterrestrial. Analysis suggested they could be consistent with an iron meteorite. It's painstaking work, but it's perhaps the closest we come to finding actual physical remnants.
Still tantalizingly close, but maybe not quite definitive yet. Okay, so we've got the event, the witnesses, the confusing evidence on the ground, the microscopic clues. Let's talk theories. What is the main scientific explanation now?
The leading theory, the one most widely accepted in the scientific community, is the airburst model.
An explosion in the air, not on the ground.
Exactly. The idea is that a stony asteroid, maybe 50 to 60 meters across, so pretty big, roughly the size of a multi-story building, entered the atmosphere at incredible speed.
How fast are we talking?
Estimates are around 27 kilometers per second. That's like Mach 80.
Whoa!
And it didn't make it to the ground. It encountered tremendous atmospheric pressure and heat, and it catastrophically exploded somewhere between 5 and 10 kilometers up.
High up. That explains the lack of a big crater, right?
Precisely. The explosion itself releases a staggering amount of energy.
How much energy? Can we compare it to something?
Estimates have varied over the years, from maybe 3 megatons of TNT right up to maybe 30 megatons, possibly even higher in older estimates. The more recent analyses tend towards the 10 to 30 megaton range.
Let's put that in perspective. Hiroshima was about 15 kilotons.
Right, so even 10 megatons is what, over 600 times more powerful than Hiroshima? It's comparable to the largest hydrogen bomb tests like the U.S. Kessel Bravo test. Just immense power.
Mind-boggling. And how often do things like this happen? Should we be worried?
Well, Tunguska-sized events are thought to be pretty rare, thankfully. Estimates suggest maybe once every 1,000 years or so, on average. Smaller airbursts happen more often, but something of this magnitude is uncommon.
Okay, that's slightly reassuring. Now, before we dig deeper into the asteroid theory, I know you want to tell our listeners something important.
I do. If you're finding this story as fascinating as we do, don't let other incredible tales like the Tunguska event remain a mystery to you.
Absolutely. Make sure you hit that subscribe button for Tell Me More Stories Told as podcast.
Yeah, join us for more deep dives into history, science, and unbelievable true stories. You won't want to miss them.
Okay, back to the theories. The asteroid airburst is the front runner. But I remember hearing about a slightly different impact idea recently. A glancing blow.
Ah, yes, the glancing impact hypothesis, proposed in 2020. That model suggested maybe it wasn't a stony asteroid, but a larger iron asteroid, maybe up to 200 meters across.
Iron, so much denser.
Exactly. And the idea was it came in at a very shallow angle, essentially skipped off the upper atmosphere like a stone on water, and then shot back out into solar orbit without actually exploding over Siberia in the same way.
A cosmic ricochet. Could that explain the damage pattern and lack of crater?
The model suggested it could produce a powerful shock wave consistent with the damage, without leaving fragments or a typical crater. It's an intriguing alternative, though the stony asteroid airburst is still more widely cited.
And how does the airburst theory explain that weird butterfly pattern of fallen trees?
It actually matches quite well with the physics of large airbursts. The intense downward pressure wave right below the blast would scorch and delimb those central trees, but could leave them standing.
Okay.
Then, The main blast wave traveling outwards horizontally would flatten the trees further away, and the shape of the object and its trajectory could easily create that sort of two-lobed butterfly pattern rather than a perfect circle. It's consistent with simulations and even observations from large nuclear airburst tests.
Right, like Operation Blowdown you mentioned earlier. Okay, so the asteroid airburst seems to fit a lot of the pieces, but for a long time, wasn't a comet the main suspect?
It was, especially early on. Back in the 1930s, the idea of a small comet seemed plausible. Comets are mostly ice and dust, very fragile.
So they could just vaporize completely?
That was the thinking. It would explain the lack of a crater and maybe even those glowing night skies, the ice and dust spreading through the upper atmosphere.
And there was a connection made to a specific comet, wasn't there? Comet.
Yes. In 1978, Ubor Krasak suggested it might have been a fragment of Comet Inc. Inky is linked to the Beta Taurids meteor shower, which peaks around late June, right when Tunguska happened. The trajectory seemed like a possible match.
A piece of a known comet. That sounds compelling.
It did. Krasak even calculated that if the fragment had arrived just a few hours differently, the impact zone could have been overpopulated areas of North America. A chilling thought.
Definitely. But the comet theory hit problems, right?
It did face criticism. Zdeněk Sakanina in 1983 argued convincingly that a fragile comet entering at the shallow angle calculated for Tunguska would likely have broken up much, much higher in the atmosphere. It probably wouldn't have survived long enough to produce such a powerful low-altitude explosion.
So it pointed back towards something denser.
Yeah, his work strongly suggested a denser rocky body, an asteroid, was a better fit for the observed effects, even without a crater.
Which leads back to the idea of the asteroid disintegrating completely in that massive airburst.
Exactly. The pressure and heat just become too much for the asteroid structure. It exceeds its cohesive strength, and boom, it blows apart, releasing all that kinetic energy almost instantly. Models by researchers like Chisai showed how this could happen.
And the physical evidence, like those tiny spheres found in tree resin, pointed towards asteroid material, too.
Right. The Italian research in the 90s found material consistent with asteroids, although the comet idea didn't totally vanish. Well, in 2009, some researchers brought up the noctilucent clouds again, arguing the amount of water vapor needed might favor a comet. They even compared it to space shuttle exhaust, creating similar clouds. There was also a suggestion linking it to a specific near-Earth asteroid, 2005 NB56.
So the debate lingered, but the Chelyabinsk event in 2013 really helped solidify things, didn't it?
It really did. Chelyabinsk was much smaller, maybe a 20-meter object, releasing about 500 kilotons. But we observed it with modern instruments.
So we got real data on an airburst.
Exactly. And using that data to refine the Tunguska models strongly reinforced the idea that it was a stony body, probably in that 50-80 meter range, entering fast, exploding around 10-14 kilometers up, releasing energy maybe in the 10-30 megaton range. Very similar energy release, actually, to the Mount St. Helens volcanic eruption.
So asteroid airburst is definitely the leading contender based on all the evidence. But what about Lake Cheko, that small lake nearby?
Lake Cheko. For a while, around 2007, there was a hypothesis that this might be the missing impact crater, or at least a crater from a fragment.
What was the evidence for that?
It's about 8 kilometers from the hypocenter. It's unusually deep and conical or bowl-shaped for lakes in that area. Seismic scans hinted at a dense object buried under the deepest point. Its long axis seemed to point towards the explosion center, and early sediment core studies suggested a possible change around 1908.
Sounded promising. A piece might have survived and made a smaller crater.
It did sound exciting, but further research kind of poured cold water on it.
Oh, what did they find?
More thorough studies, especially soil analysis and dating by Russian scientists in 2017, indicated the lake is much older. Likely at least 280 years old, maybe much more.
How could they tell?
They looked at sediment layers and even found traces of radioactive fallout from mid-20th century nuclear tests at depths, suggesting slow, long-term sedimentation, not a sudden formation in 1908. Plus, impact physics suggest it's really unlikely a 10-meter fragment would survive intact to make a crater like that after the main airburst.
Okay, so Lake Cheko is probably just an interesting old lake that happens to be nearby.
That's the consensus now, yeah. Not the smoking gun crater.
So if it wasn't an asteroid or a comet fragment hitting the ground, and Lake Cheko isn't the answer, were there any other, maybe more out there theories?
Oh, there have been plenty over the years. Some less conventional ideas have focused on geophysical origins.
From the Earth itself?
Yeah. For instance, the astrophysicist Wolfgang Kundt proposed a massive sudden release of natural gas maybe 10 million tons from the Earth's crust.
Natural gas exploding.
The idea was the gas cloud rose, maybe drifted, got ignited somehow, and the fire traced back to the source, causing a huge explosion. There's also the Verneshot hypothesis, a similar idea involving geological gas release.
Interesting ideas, but are they widely supported?
Not really within the mainstream geological or astrophysical communities. There isn't strong geological evidence at the site pointing to such a massive explosive gas release in 1908. The impactor theory just fits the wide range of evidence much better.
And of course, fiction loves Tunguska, right? Aliens, black holes.
Absolutely. Alexander Kazantsev's 1946 story Explosion really popularized the idea it was an exploding alien spaceship, which captured the public imagination for decades. Micro-black holes were another popular sci-fi explanation for a while. The mystery lends itself well to fiction.
It really does. So wrapping this up, the Tunguska event remains this incredibly captivating mystery.
Totally. While the meteor airburst of a stony asteroid is definitely the leading scientific theory, the absolute lack of a smoking gun crater and some of those odd lingering effects mean there's still room for fascination and debate.
And the sheer power of it. Flattening a forest the size of a major metropolitan area being felt across continents. It's a stark reminder of the cosmic forces at play right here in our solar system.
It really is. What's amazing is how this event, in such a remote place over a century ago, still drives scientific research and starks our imagination today. The mystery endures.
It makes you wonder, doesn't it? What aspect of Tunguska stands out most to you listening right now? Does the asteroid theory feel complete, or do some of those other ideas still hold some appeal?
It's definitely something to think about. We encourage you to keep exploring this incredible story. Who knows, maybe the next big clue is still out there, waiting to be found, to finally tell us exactly what happened that day the sky exploded over Siberia.
A truly fascinating journey into one of history's great mysteries. Thanks for joining us on Tell Me More Stories Told as podcast.